We're going to look at a game called Towers of Hanoi in this video. Towers of Hanoi is a very famous problem in computer science, and the reason that it's famous is because it's very easy to develop a recursive solution to Towers of Hanoi, and it's very hard to come up with a solution that doesn't use recursion. So in this game, the goal is to get all of the disks here from the peg on the left to the peg on the right. And the one rule of the game is that you can never put a larger disk on top of a smaller disk. So if I move this one here, I can't move this one on top of it. So instead, I can move this over here, for example. This is not the most efficient solution to this problem. Whoops. And we'll move this one here. Okay, so at this point, all of the disks are over here, and the game's over. So we can see that this took me 12 moves, and the minimum required for 3 disks is 7 moves. So I had a suboptimal solution. What we're going to do is we're going to write a program that will generate instructions to solve this game in the minimum number of moves every time. So if we think about how this game works, we have n is going to be the number of disks that are used, and then from is a character that indicates the peg that we're moving from, to is the peg that we're moving to, and temp is the other peg, the third peg. So in this case, we would call this, let's say, peg A, and this would be peg B, and this would be peg C. So we want to move n disks, which is 3 disks, from peg A to peg C, and the other temporary peg is peg B. So if we think about this, what we really need to do is we need to move basically all of the disks that are on top of the bottom one to the temporary peg. Then we need to move the bottom disk from the start peg to the target peg. Then we need to move all the other disks from the temporary peg to the target peg. So basically what these high-level things are saying is that we want to move all of these that are on top of the bottommost peg over here, and then we want to move the orange one over here, and then we want to move all the ones that were on top of it from this peg over to here. So when we develop a recursive solution to a problem, we need to think of the base case, which is the very simplest case. I would argue that the simplest case here is when there are no pegs, when n is 0. So if n equals 0, there are no pegs, we're just done. So we're just going to return because there's no work to do. Otherwise, we're going to follow this basic algorithm, right? So the first thing we need to do is we need to recursively call the Towers of Hanoi method to move the n-1 disks from the start peg to the temporary peg using the target as the temp. So we'll call Towers of Hanoi, and we will pass it n-1. This is the recursive step where we're getting closer and closer to n being 0. And then we want to move them from the from peg to the temporary peg. So now the 2 is going to be the temporary peg, and the temp is actually going to be the one that was the 2 peg before. And then we're going to print out move from the from peg to the 2 peg. And then we're just going to make this call again one more time. Only now we're going to move the n-1 disks from the temporary peg to the 2 peg with the from peg as the holding spot. So I'm going to stop the video here, and then in the second video for this week we're going to look at the driver program and then run this and see what kind of output we get.